Hello my dear lovely students, I hope all of you are doing well and keeping safe also. In the last video, if you remember, we discussed about what is really meant by the polar form of a complex number. If you still haven't, please go and check out the previous videos so that this video will be easier for you to understand. So today in this video, what we will do is we will try and solve some exercises, some questions based on the polar form of a complex number. That is, we will try and solve exercise 5.2 from the NCERT textbook, and we will try to solve as many questions as possible, even though there are not many questions in the exercise. I would also try to make one suggestion, that is, try and get some other books of mathematics other than the NCERT textbook also for your practice. And yes, today I would also like to request all of you that I believe that you already have. If you still haven't, please make sure that you do subscribe to this channel. Help me reach out more and more students who are in need, who cannot afford tuitions. And yes, it will also be very helpful for you during the examinations. Maybe you're preparing for tomorrow's examination, so tonight you don't have any teacher around you. You can always check out this channel and then maybe clear some doubts, which will, I believe, which might help you clear some doubts and make you prepare for the next day's examination when you have examinations. Alright then, so let us begin. The first question was, find the modulus and argument. I haven't written down the full question. Okay, find the modulus and argument of the following complex of each of the complex numbers in exercise question number 1 and 2. Both the questions I've written. We'll start off with the first one, modulus. So modulus, as we studied, it's not very difficult. What was the modulus of z is equal to x plus iy? The modulus of z was simply sum of the squares of the real and the imaginary parts. So sum of the squares of the real and imaginary parts. Only the numerical values. Remember, we never use the value of I. Only the real and the imaginary parts only. Okay? So that's going to be 1 plus root 3 minus root 3 squared. That's 3. So that will be root over of 4. That is going to be 2. The argument. There are 3 different ways of finding out the argument. Generally, I prefer the method which I gave in that previous video, directly finding out the argument if we can get the quadrant of that complex number. So here, the polar coordinate. What is the polar coordinate here? It's -1 minus root of 3, ignoring this I. Polar coordinate only in the argent plane. Now, we studied in that last video. So this lies in which quadrant? Lies in, so minus, I think it lies in the third quadrant. It lies in the third quadrant. So in the third quadrant, our argument of z, which is actually theta, will be equal to what? I think I gave you, if it lies in the third quadrant, the argument will be simply tan inverse y by x minus pi. You can check out the previous notes if you have already written it down, and you can take the help of that note. So modulus is already done. So we're trying to find out the argument. So this is going to be argument, or theta will be tan inverse. What is the value of y here? Yeah, another important note is that use only the positive. I'll just write here like this. Use only the positive values of x and y. Okay, ignore the negative values when we're trying to find out the argument, tan inverse of especially this y by x. Ignore the negative values. Alright, so tan inverse y value is root of 3, x value is 1 minus pi. So that will give us tan inverse root of 3 minus pi. Now, root 3 corresponds to which trigonometric ratio of which specific angle of tan? If I'm not wrong, in that case, root 3 is tan of 60. Tan of 60. So that's going to be pi by 3 minus pi. So tan inverse tan will be 1. So that's going to be pi by 3 minus pi. Now this inverse trigonometry function in the last video also I discussed. This inverse trigonometric functions, basically you will learn more about it in class 12. Okay, so for now you just understand that tan inverse tan, I told you in the last video also, or sine inverse sine, cos inverse cos will be 1. Just that nothing should come in between these ratios. Alright, no minus, no plus, no numerical values, nothing, just the trigonometric ratios. So we have pi by 3 minus pi. So if we just take the LCM, pi minus 2 pi, 3 pi, sorry. So we have minus 2 pi upon 3. So our modulus was 2. Argument is minus 2 pi upon 3. Alright, I hope you have written it down. Okay. So that's it. Let's go to the next question, that is number 2. Now number 2, let's find out the modulus first. That is magnitude. That is sum of the squares of the imaginary and the real parts. Imaginary part, it is minus root 3. Real part, I into 1. So that will be 1. So that's again going to be 3 plus 1. That is again going to be 4. That is again going to be 2. Almost same like the last question. Here, what are the polar coordinates here? Minus root 3 and 1. So minus root 3 and 1 lies in which quadrant? Minus root 3, 1 lies in the second quadrant. So in that case, what will be the argument of the complex number? If it lies in the second quadrant, you can check your previous notes. What did I give you? You will simply use pi minus tan inverse of y upon x. So pi minus tan inverse, what is the value of y? The value of y is, okay, I'll just write it. X is minus root 3, y is 1. So 1 upon, what did I say? Previous question. Please only use positive values only, ignore the negative values. Root of 3. I think I can rub this off. So that's going to be pi minus tan inverse. Now 1 by root 3, that corresponds to tan 30 degree. Tan 30 degree. Now tan 30 degree is what? Pi by 6. So that's pi minus pi upon 6. So if you just take the LCM and calculate, you will have 5 pi upon 6. So this is the argument of the second question. Modulus was 2. Argument is 5 pi upon 6. Done? Okay. Let's move on to the third question, which says convert each of the following complex numbers, the main questions now, in the polar form. Convert each of the given complex numbers in the polar form. Number 1, that is 1, let us assume z, 1 minus I. So it's almost the same, only modulus we'll find out. Because what was the value of the complex number? It was r cos theta plus I sin theta. What was the value of r? It was root over of x square plus y square if our complex number is x plus iy, which is also same as the modulus of z. So here also we will find out the modulus of z, that is root over of sum of the squares of the real and imaginary parts, 1 plus 1, that is root over of 2. Then here, what happens? What are polar coordinates? Plus 1, minus 1, isn't it? Plus 1, minus 1, because the real part is 1, imaginary part is minus 1. So in the polar coordinate, that is in the argent plane, the polar coordinate will be 1 and minus 1. Lies in which quadrant now? 1 minus 1. So 1 minus 1 lies in which quadrant? Plus 1, minus 1. So plus 1, minus 1. So this lies in the fourth quadrant, right? Plus, minus lies in the fourth quadrant. So in that case, what is the argument of z? That is theta. So that will be simply minus tan inverse of y upon x. So that's going to be minus tan inverse. What is the value of y here? 1. Positive values only. X is 1. So let me just rub this off now. So that will give me minus tan inverse of 1. Now, what is 1? How can we represent 1 in terms of tan? We will use tan 45 degree, that is pi by 4. So tan inverse tan will be 1, so we have minus pi upon 4, minus pi upon 4. So now we have the argument and we have the magnitude or the modulus of the complex number. So the polar form will be simply z is equal to r cos theta plus I sin theta. So what was the value of r? Root over of 2. Cos theta we have minus pi by 4 plus I sine of minus pi by 4. So this is your polar form of a complex number. No need to convert it, let it be, because this is the polar form of the complex number. Okay, alright, so if you are done, let's move on to the next question. That is the next question. Let us try. Okay, next question, let us try, let's say number 5. I'll skip number 4 because they are similar questions. So let's maybe some questions you can try on your own, and do let me know if you are not able to get the solution. Please let me know in the comment section. I will solve it for you. So let's find out its magnitude. Magnitude of z will be minus 1 square plus minus 1 square, because here also, what is the value of x? Minus 1. What is the value of y? Minus 1. So 1 plus 1, that is root over of 2. Same again. Here, what are the polar coordinates? Minus 1, minus 1. So polar coordinates lies in which quadrant? Minus, minus. Lies in the third quadrant. So in that case, what will be our argument? Third quadrant, in that case, it's going to be tan inverse y upon x minus pi. So that will be tan inverse y upon x minus pi. That should be tan inverse 1 minus pi. I'll just continue here. So that will be tan inverse 1 is tan 45, that is pi by 4 minus pi. So we have pi by 4 minus pi. So that's going to be pi minus 4 pi upon 4. That will be minus 3 pi upon 4. Minus 3 pi upon 4. This is question number 5. Minus 3 pi upon 4. So then we have the argument, we have the magnitude or the modulus. So let's write our polar form. So what will be the polar form? The polar form will be z equal to, okay, I'll just write r cos theta plus I sin theta. So what was the value of r? Root over of 2. Cos theta is minus 3 pi by 4 plus I sine of minus 3 pi upon 4. Okay, alright, let's try number 6. Question number 6, our complex number is z is equal to minus 3. Now, if you remember, z equal to minus 3, okay, let's just find out the magnitude first. So that's going to be, this is like purely real, isn't it? We'll discuss about that. So, what is the value of x here? Minus 3. What is the value of y? 0. So, plus 0 square. So, that's going to be 9. That's going to be, of course, 3. Now, here, what happens is z is purely real, and the value of x is minus 3, which is actually less than 0. So if you remember, if you can check the previous notes, I've given you the tricks on how to do it quickly. That is, if x is equal to minus 3, which is less than 0 for a purely real complex number, then in that case, what should be our theta? I think our theta was expected to be pi, isn't it? So that's how we get the value of the argument directly. So in that case, so what will be our complex polar form of the complex number? Z equal to r cos theta plus I sin theta. R cos theta plus I sin theta. Question number 6. So 3 plus cos pi minus plus I sin pi. Okay. Alright, this is for purely real. There's one more question that I see there. Okay, number 8. I think I can rub this off now. Shall we do one more question? 7. Z equal to root 3 plus I. Let's do it quickly. Z is equal to root over of root 3 square plus 1 square. Again, x is root 3, y is 1. So that's going to be 3 plus 1, that is going to be 4, so that will be 2. And here we have root 3, root 1. So these are both positive, lies in first quadrant. So what will be our theta here? Theta will be simply tan inverse y upon x. So that will be simply tan inverse, what is the value of y? 1. X root 3. So that can be written as tan inverse tan 1 by root 3 is tan 30 degrees. So 30 degree in the radian form can be written as pi upon 6. So that is theta is pi by 6. So our polar form will be z equal to 2 cos pi by 6 plus I sin pi upon 6 for question number 7. Okay, alright then. So let's wind up with the last question. Question number 8, sorry. Now, I would also like to share with you that this channel was purely created for you, my dear lovely students. Because not every student is fortunate enough to go to afford tuitions, coaching classes, especially again during this pandemic when all the coaching classes are also not running, schools are not running. So this medium I have developed for you students only, so that you'll have a place to learn. And this YouTube, of course, is always very useful, because some of you may be having may not be having personal smartphones at home. Your parents might be going out for work during the daytime and all. You may not be able to attend online classes and all. So when they come back in the evening, at night, or early in the morning, you can always get that phone and then just watch. And then as well as I'm trying to solve all the exercises also. There's a lot to be done. I'm trying to catch up also. I'm trying to finish up as much as I can. So this channel is generally created for students, for learners, I would rather say, okay, for learners who are trying to learn. I'm not saying that I'm the best, I can give you the best. I'm just okay only, okay, but I'm just trying to give you what I know. I'm just trying to share what I know with the students. I may not be the best. I am not the best. Nobody is the best. But I'm just trying to share with my dear students who are trying to learn. So please help me reach out to maximum of the students so that they can also all can benefit. All can benefit through this particular medium. That's what I want. That's why I created this schedule. Created this channel generally for students who are trying to learn. And as I say, I'm not telling you that I am the best. I am not. But I'm just trying to give you what I know. I'm just trying to give you what I know. And I'll be very happy if you are learning from this channel. Then I will be very, very happy. That's all I want. I'll be happy with that. Now, going back to this channel, that is that, not channel, to this question, z equal to I. If you see this, this is a purely imaginary number. There is no real part involved here. So anyway, here real part is 0, imaginary part is 1. We will have to find out its magnitude, that is 0 square plus 1 square, that's going to be 1. Since z is equal to I is purely imaginary, where y is equal to 1, which is greater than 0. Where y equal to 1, which is greater than 0. This notes also I gave in the previous video. Please do check out that video. So what will be my argument? Theta will be, if y, the value of the imaginary part is greater than 0, then this will be pi by 2. That's it. So therefore, the polar form. So therefore, the polar form of the complex number z will be equal to r cos theta plus I sine theta. So this was, so if you can understand the concept, it's as simple as that. So this exercise is not very difficult. Please do study, make use of this, especially this algebra portion in class 11. Very, very helpful and very, very interesting also. Alright, then I'll leave you here. So I hope you have learned this exercise well enough. Maybe in the next we will start with a new chapter, new topic. Let's hope that we learn that particular chapter also soon enough. Okay then, till then, take care, stay safe, study well, and prepare well for your examinations also. Bye bye.